So first of all, so I got this division problem that I started. I didn't finish it, right? So let me go ahead and, browse through this. You probably already know this, but I'm going to go ahead and browse through this quick. So I had this negative x to the 4th. One of the things that you need to be careful with is you need to, if there's a term that's not there, so you double check the exponents, especially when you get into synthetic division. You got to make sure that all your terms are there. So x to the 4th, x cubed, x squared, x 12. And so in this case, the x squared term was missing, so we have to put a 0 there. So that makes a big difference. And this was a kind of a weird problem because we end up with all these extra zeros up here, but I'm not going to worry about that. So in this case, I was taking this x to the 4th thing and I was dividing it by x minus 7. And so remember that we have these steps when we go through long division. So the first thing is we divide. We take the first term, divide it by the first term. So negative x to the 4th, divide by x, and I get negative x cubed. And stop me if I say something that doesn't make sense. So one of the things that I like to point out, one of the reasons why I'm doing this, because you actually asked about synthetic division, is because we're dividing by exactly x. And in synthetic division, that is always true. Because we're dividing by exactly x, these two terms are exactly the same except for the exponent. So we're going to use two of those ideas, two parts of that when we're doing synthetic division. So number one, in synthetic division, we always carry down the first coefficient. And this is why, because our answer is always going to have the same coefficient as our problem started with, because we divided by x. Okay, dividing by x does not change the leading coefficient. So in synthetic division, that's why we pull down the leading coefficient. And then the other thing is when we read off the answer is always going to start with a degree that's just exactly one smaller than the one that we started with. So if I knew that I had x to the 4th, I know that my answer is going to have an x to the 3rd at the beginning. Okay, those two pieces of information about synthetic division come from that fact. Okay, so when we keep going through our long division, so the next step would be multiply. So we take that negative x to the 3rd and we multiply it by the whole x minus 7 and distribute it across. And then the next step is we subtract. So I took the first two terms that I have here and I subtract these two terms here. In this case, I got 0. So the point that I want to make at this point, 2 points. Number one is this term is always going to drop out. At every step that we do this long division, that first term, we design it so that that first term is gone at the end of the step. So that's not very interesting. What's interesting is what number we get for the second half of that subtraction. Okay, so in synthetic division, at each step, instead of writing both of these numbers down, we're just going to write the second number down. Okay, plus we're not writing the x cubed, the x's or the exponents or the plus signs. Okay, the other thing is that we're subtracting. Long division always uses subtraction. So in this case, I had a 7x cubed because I took negative x cubed and multiplied by negative 7, and I got a positive 7x cubed. But then I was subtracting it. So that ended up being, I was subtracting a positive 7, which meant that I ended up adding a negative 7. My writing's a little sloppy there. So my point is that remember that in long division, you're subtracting, but in synthetic division, instead of subtracting, we're going to add the opposite. So it's making it easier because we're taking that subtraction at every step and we're turning it into an addition instead of a subtraction. So that's what I wanted to point out from that so far. So let's put those pieces together and let's do this problem using synthetic division. So I had negative x to the 4th, so I'll write down the negative 1. So I'll put the 7, and then I had no x squared term, so the 0 is really important at this point when you're doing synthetic. And then I had a 2, and I had a negative 12. So I don't write any plus signs, I don't write any x's, I don't write any exponents. So I was dividing by x minus 7. And so with synthetic division, what we do is we strip away the x minus part of it and we keep whatever we have left. So instead of using negative 7, I'm using positive 7. So by using the opposite, that's what allows me to do addition instead of doing subtraction. So I'm using the opposite so that I can add instead of subtract. So I said that we bring our leading coefficient down. We already talked about that. And then we have this repetitive process. So for long division, 2 of the steps were divide, subtract, or multiply, subtract, multiply, subtract. So in this case, we are multiplying. So I'm going to do green as multiplication. And then we're going to add instead of subtracting. So if I take, if I want to color code this, I need to be able to hold my markers without dropping them. So the answer to that goes right here. So 7 times -1 was -7. And then we take those numbers and we add them. So this time around I got 0. And then I take that 0 and I multiply it. And so 7 times 0 is 0. So that answer goes there. And then I take those two numbers and I add them. And then I take, whoops, I missed, 0 times 7 and I get 0. And then I add and I get 2. And then I multiply 2 times 7 and I get 14. And I take -12 times 14, or -12 plus 14, and I get 2. So I added. So you can see how much quicker that is than actually doing the long division. And if I took the problem and put it back, you can see where all the numbers paralleled. So this was an x to the 4th up here. That was a 1x to the 4th. So now this is going to be a 1x cubed. So that means that this is a 0x squared. So this is a 0x. So this is a 2. So that's your constant term. And your last term is your remainder, which if you wanted to, you could write it over the divisor. Just got to understand the little pieces. But obviously it's synthetic division. It's an artificial device. There's some stuff going on backwards there because we are adding the opposite instead of subtracting. And so, of course, obviously, it's going to take a little bit to get used to. But hopefully it makes more sense when you compare it to what you're doing in long division. So you can see the parallels, so it doesn't seem quite as artificial. So hopefully it'll feel a little more comfortable than it did to begin with.